Good evening all. So National Testing Agency has announced CSR net exam for this June 2024, right? So as per the notification, we need to prepare for this joint CSR UGC net examination 2024. So they have released the notification on 1st May only. So just we got notification. So here if you look at this CSR net examination June 2024, so schedule is as per this below. So submission of online application form is going to be from 1st May to 21st May. After that, last date for the payment fees is going to be up to 23rd of May. Okay, then correction window they will give from 25th to 27th. If you have any corrections in your applications, so you can make it correct. So after that, date of exam is going to be from 25th, 26th and 27th of June. Okay, so still we have a lot of time from, if you consider from this May 3rd to, so up to June 25, 26 or 27. So out of these 3 days examination will be conducted. So it will be basically CBT based, that is computer based test, and pattern of the examination will be MCQ only, objective type, that is MCQ with MCQ. Then it will be in English and Hindi both. So especially with this channel, we are going to revise the classes for basically for physical sciences. Okay, and apart from these, we need to see the syllabus that is prescribed by CSR, National Testing Agency. Especially the CSR UGC National Eligibility Test for Junior Research Fellowship or Lectureship is given as this below. So here we are going to look after the syllabus that is prescribed here. The first thing is that part A core, that is almost basic part will be there. After that, advanced part will be discussed. So within these days, from what is that dates, especially from June 26, 26, 27 or 25. So these will be the dates, right? Yes, 25, 26, 27. So we can cover maximum parts of all the syllabus they have prescribed for physical sciences. Especially we are going to deal mainly with mathematical physics, right? Then after that, classical mechanics. In mathematical physics, we are going to deal all these linear algebra, matrices and Hamiltonian theorems. Then Fourier series, Fourier transform, and all these special functions, differential equations, that is Hermite polynomial, Bessel function, Lagrange and Legendre polynomials. After that, Fourier series, Fourier and Laplace transforms. Then complex analysis, analytical functions, Taylor and Lorentz series. Then complex analysis, everything. Okay. So after that, classical mechanics will be basic part. Then in this channel only, or by using online classes, we had covered like for KSET syllabus, we have covered lot of syllabus. So the same syllabus will be covered here, but it will be revision classes. Okay. Then main thing is about Newton laws and dynamical systems in classical mechanics, phase space dynamics. It is completely Lagrangian mechanics, not basically about the Newtonian laws will be discussed, but not completely Newtonian mechanics. So after that, we can discuss about the electromagnetic theory, that is about the basic part, and these all syllabus will be for only BSc science students only. So this classical mechanics part and electromagnetic theory part, right? So up to we can discuss these parts up to this coherence and diffraction and dynamics of charged particle in a static and uniform electromagnetic fields. So So all the parts up to from electrostatics, Gauss law, and all these applications, Laplace and Poisson's equations, and boundary value problems, and the complete magnetostatics will be covered based on the BSc syllabus. Okay, so after that we can complete, we can revise the syllabus for quantum mechanics. So in this revision, we are going to mainly focus on the basic formulas, means important formulas. Then after that, some previous questions, PYQs, previous year questions. Then after that, if candidates are interested, we can conduct even online test series also. So if you are interested, you can comment me, and you can text me also to my number. Then after that, in quantum mechanics, we are going to discuss about the wave particle duality, Schrodinger equation, and time independent, dependent and independent equations, the eigenvalue problems, and tunneling and through the barrier, wave functions in a momentum representations, commutator and Heisenberg uncertainty principle, Dirac notation, and state vectors, and complete quantum mechanical part like hydrogen atom, Stern-Gerlach experiment, time dependent perturbation theories, variation principles, that is variational method, time dependent perturbation theory, and Fermi-Golden rule, selection rules, so Pauli-Ascoli principle, static spin statistics connections. After that, in thermodynamical parts and statistical physics, we are going to discuss all the thermodynamical and their consequences, then thermodynamic potential, Maxwell relations, then chemical potential, phase equilibria, phase space, macro states, microcanonical, canonical, and grand canonical. And after that, we are going to discuss about all the distribution laws like classical and quantum distributions laws, Bose-Einstein, Fermi-Dirac distributions, and black body and Planck's distributions also. So after that, in electronics, we are going to discuss mainly about the diodes, junctions like transistors, field effect transistors, and all these optoelectronic devices like LEDs, photodiodes, solar cells. Okay, then digital techniques and its applications also we can discuss later parts. So this is about mainly about the basic parts of physical science syllabus that I have prescribed for CSR net. So after that, we can discuss about the advanced concepts. So whenever I start the basic topic, like if I consider this quantum mechanics, then I will cover up both basic parts as well as advanced parts. Okay, so in advanced part, we are going to discuss like mathematical methods of physics, the same thing that is covered as a little bit advanced here, about the partial derivatives, differential equations, Laplace, and heat equations in 2 and 3 dimensions. Then even you can discuss about the computational techniques like root of functions, interpolation, extrapolation, integration by trapezoid and Simpson's rules, and solution for first order differential equations, and Runge-Kutta method. So we'll look after these things later, after completion of all the basic concepts like classical, quantum, ED, electrodynamics, and everything. So in classical part, so it is phase space dynamics and stability analysis, Poisson's bracket, and canonical transformations, electromagnetic theory. So it is a little bit advanced part of relativistic on electrodynamics here, and quantum mechanics, WKB method, and spin orbit couplings, then elementary theory of scattering and Born approximations, and relativistic quantum mechanics mainly. Okay, so in thermodynamic parts, we are going to discuss about like first order phase space transitions, diamagnetic and paramagnetic magnetism, ferromagnetism, then Ising models, and Bose-Einstein condensation, diffusion equations, and random walk Brownian motion. So after that, we can discuss about the introduction of non-equilibrium process. So linear and non-linear curve fitting in case of experimental method. So these questions will be asked only very less. We'll see if we get a lot of time to cover up all these things. You can cover these parts of electronics and experimental methods also. Okay, then we can cover for the advanced topics like what are these, like atomic and molecular physics. So these covers maximum parts. Okay, then in case of atomic and molecular physics, quantum states of electron in a atom, electron spin, spectrum of helium and alkali metals. So these parts like atomic and molecular and condensed matter physics and nuclear and particle physics. So these will cover a lot of syllabus, a lot of questions from CSR net. And relativistic in this part, atomic and molecular, so we are going to cover up relativistic corrections for energy level of hydrogen atom, hyperfine structures, then isotopic shift, width of spectral lines and LS and JJ couplings, Zeeman Paschen bracket, then Paschen-Back and Stark effects, electron spin resonance, nuclear magnetic resonance, then chemical shift, Planck quantum principle, then Born approximation, that is Oppenheimer approximation, electronic and rotational, vibrational and Raman spectra of diatomic molecules and their selection rules. After that we can discuss about the lasers and its coefficients, then what exactly optical pumping and everything. So mainly here problematical part will be main important than theoretical one. Then after that we can discuss about the condensed matter physics, that is going to be carried from its basic parts like reciprocal lattices, then Bravais lattices, its structure, bonding of the in solids, elastic properties, phonons, lattice specific heats, free electron theory, electronic specific heat, response and relaxation phenomena, Drude model of electrical and thermal conductivity. So these are very important parts. Hall effect and thermoelectrical power is also important one. So electron motion in a periodic potential and band theory of the solids, metals, insulators and semiconductors, superconductivity even, that is type 1 type 2 superconductors we can discuss, Josephine junctions and superfluidity. So up to this we can cover a lot of parts of the questions that will be asked in CSR net and even KSET also. So nuclear and particle physics, in nuclear and particle physics mainly, so it involves the basic part of what we can call the nuclear physics. Okay, here we can discuss about the nuclear properties, binding energy and everything, nature of the nuclear force, then form of nuclear and potential, charge independence and how that charge independence is there, and charge symmetry of the nuclear forces, then neutron problems, evidence of the shell structure, single particle cell model, its validity and limitations, rotation spectra, elementary ideas of alpha, beta and gamma rays. So these maximum part will be from BSc parts. So if you are good at your BSc concepts, you can cover maximum parts of the CSR net syllabus. And even fission and fusion also, then the nuclear reactions and reaction mechanism, compound nuclei and direct reactions also. So classifications of fundamental forces, there where we are going to study about the elementary particles and quantum numbers like spin, charge, then parity, isospin and everything. So Simultaneous. Gelman-Nishijima formula is very important. Almost all these parts like applications of the symmetry and arguments of the particles reactions, Brillouin-Mason's, CPT invariance. So this will be asked at least 2 to 4 problems will be asked compulsory in one KSET as well as net syllabus. Okay. So from tomorrow onwards, I am going to have from 7 to 8 evening a live classes for the revision for CSIR net 2024, that is June 2024. Okay, so this is what I wanted to tell, and we are going to start from tomorrow onwards. If you are interested, you can join the channel, and even you can and you can even interact with me through WhatsApp group. I will give the WhatsApp group description here. So I'll see you tomorrow then.